All right, here we go. Lesson 4, distances and circles. Let's build an equation for a circle. That's the goal for this lesson. 4.1, going the distance. Andre says, I know that I can find the distance between 2 points in the plane, so P and Q, by drawing in a right triangle. So he draws this right triangle and using Pythagorean theorem. But I'm not sure how to find the lengths of the legs of the triangle. So there's one leg, Pn, and there's another leg, Qn. When I can't just count the squares on the graph. So there's no like grid that you can count, basically. Explain to Andre how he can find the lengths of the legs in the triangle in the image, then calculate the distance between points P and Q. So there's P, there's Q. Okay, so P is 8, 12. So right here is 8. And Q is 53, 22. So the distance between P and N is just the difference between the x's. So 53 minus 8. So 45. So this one is 45. Because you just take the x coordinates and find the difference. Same thing goes for the y's. So up here is 22, and right here is 12. So the difference in the y coordinates is 10. And then we got to calculate the distance between P and Q. So remember, you got a right triangle, so you could just go a squared plus b squared equals c squared. So that is, let's just go 10 squared plus 45 squared equals c squared. So 100 plus, get a calculator for that part. $45 squared is 2025. So 100 plus 2025 equals c squared. So 2125 equals c squared, and then take the square root of both sides. That'll give you c. So second, x squared 2125. Second, x squared 2125 is 46.09. 8. So c equals 46.1. That represents PQ. So PQ equals 46.1. Let's see if they give you inches. Nope. So this one's just units. Okay, let's go to 4.2. Circling the problem. So here we go. The image shows a circle with center 6, 10. So there's your center of the circle. And the radius is 17 units. So from the center to any point on the circle is 17 units. The point 14, 25. So there's 14, 25. It looks like it might be on the circle. Verify if it really is on the circle. Explain or show your reasoning. All right, so 1425. Let's just say it's like right here. We don't really know yet if it's on the circle or not. So that's 14, 25. So to find out if it's really on the circle, you got to draw a right triangle and just see, is this 17? If it is, then it's on the circle. So let's look at the x's. 14 and 6. That means this is 8, right? The difference in the x's, 14 and 6. Difference is 8. Now 25 and 10, that difference is 15. So then because this is a right triangle, you're going to say 8 squared plus 15 squared equals c squared. We don't know. We got to find out if this checks out to 17. So 64 plus 225, does it equal 17 squared? Let's find out. 225 plus 64 is 289. And then take the square root of both sides. Second, x squared, 289. So 17, so it indeed is on the circle because this distance right here is 17. And the definition of a circle is all the points that are the same distance away from the center. And the radius is 17, so because 1425 is 17 units away from 610, we can say it is on the circle. All right, let's look at 22, 3. So there's like 22 right there. 3 is like right here. So I'm thinking it's not, but we'll find out. It's the same deal. This one I'm going to use a different color so we don't get confused. But basically what you want to do, so this is 22, 3. You want to figure out what this distance is, and that's just going to be the difference in the x's. So 22 minus 6. 22 minus 6 is 16. And then 10, the y-coordinate, minus 3, this one is 7. So if 16 squared plus 7 squared equals 17 squared, then we're good. So let's figure it out. 16 squared plus 7 squared, does that equal 289? So 16 squared is 256 plus 49. So 305. Second, x squared, 305. 17.46. So this length right here to 22, 3 is 17.46. So that point's actually going to be out here a little bit, meaning it is not on the circle. That one's not on the circle. This one is on the circle. And the way you find it is you just test if the hypotenuse equals the radius. Okay, in general, how can you check if a particular point xy is on the circle? Well, draw a right triangle. That's the first thing. 2 is find the legs using the coordinates. Third thing is run Pythagorean. If a squared plus b squared equals your radius squared, then the point is on the circle. So if a squared plus b squared equals your radius squared, then the point is on the circle. All right, let's go to 4.3, building an equation for a circle. The image shows a circle with center -3, 6, and a radius of 13 units. So from there to xy, is 13. Write an equation that would allow you to test whether a particular point x, y is on the circle. So what you do here is you do the same thing. You just draw your right triangle, right? Which we've learned from previous lessons. So you draw this right triangle here. Okay, and you copy your previous one. Draw a right triangle, find the legs using the coordinates. Okay, let's figure that out. So this distance right here, let's just call this thing A, B, C. All right, so AC is whatever the x is, so x minus -3. That's the difference in x's. Up here, this is the difference in y's. AB is just going to be y minus 6. So that's the difference in y's. Now, you're going to say x minus -3 squared plus y minus 6 squared equal your radius squared. Why? Because it's a right triangle. So this one squared plus this one squared should equal whatever your radius is. This one's 13. So in this one, you're going to say x minus -3 is x plus 3 squared plus y minus 6 squared. Does it equal 13 squared? So that's your answer. So write an equation that would allow you to test whether a particular point x, y is on the circle. Okay. Use your equation to test whether 9, 1 is on the circle. So, let's see. We're just going to plug in 9 for x. So 9 plus 3 squared plus 1 minus 6 squared. Does it equal 13 squared? So it is 12 squared plus 1 minus 6 is -5 squared equal 169. So it is 144 plus -5 times -5 is 25 equal 169. It does. 44 plus 25 is 69 plus the 1. So yes, 169 does equal 169. So 9, 1 is on the circle. So 9, 1 is on the circle. Cool. Suppose you have a circle with center HK. So remember our center here. So if it was HK, this one is -3, 6. Right? And radius R. So HK equals -3, 6. R equaled 13. So in this case, you would say, suppose you have a circle with center HK. That just means like you don't know the actual coordinates. It's just HK. So see how we did x minus -3? So it's just going to be x minus h, right, squared plus y minus k squared equals your radius squared. So, if you have a circle with center HK and radius R, write an equation that would allow you to test the particular point x, y is on the circle. It's just going to be x minus h squared plus y minus k squared equals r squared. And that is your equation for a circle. All right, that was a lot.